Welcome back to my channel, Trash to Teach.
Edge serverless applications. One personalization at scale. Example, e-commerce product recommendations. Traditional, fetch user profile from database, calculate recommendations server-side, return response. 300 milliseconds. Edge. Store user preferences in Edge key value store, compute recommendations at Edge using ML model, return response. 25 milliseconds. Better experience, lower latency, same functionality. 2. Authentication and authorization. Example, JWT validation. Traditional, every API request goes to origin server, validates JWT, checks permissions, processes request, 200 milliseconds plus processing time. Edge, validate JWT at Edge, check permissions against Edge cache, only forward authorized requests to origin, 10 milliseconds plus origin processing. Unauthorized requests never hit your backend. Huge security and performance win. 3. API aggregation and transformation. Example, mobile app backend. Traditional, mobile app makes 5 separate API calls to different microservices, waits for all responses, multiple round trips, high latency. Edge, validate JWT at Edge. Check permissions against Edge cache. Only forward authorized requests to origin 10 milliseconds plus origin processing. Unauthorized requests never hit your backend. Huge security and performance win. 4. Bot detection and rate limiting. Example, protecting APIs from abuse. Traditional, all traffic hits your servers. Application logic detects bots. Rate limiting applied at application layer. Edge, bot detection at Edge using ML models. Rate limiting applied before traffic reaches origin. Malicious traffic blocked globally. Your origin servers only see legitimate traffic. Massive cost and performance improvement. 5. Image optimization. Example, responsive images for web and mobile. Traditional, store multiple image sizes, serve appropriate version, or resize on backend servers. Edge, store original image, resize and optimize on demand at Edge, cache result at Edge. First request slightly slower, all subsequent requests instant. Real example, news site reduced image bandwidth by 60% and improved load times by 40% using Edge image optimization. The developer experience revolution. What makes Edge serverless truly transformative is how easy it's become. Traditional Edge deployment, before Edge serverless. Modern Edge serverless. No infrastructure, no configuration, automatic global distribution. Here's where it gets really interesting. Serverless databases are also going global. You can now process data and store data at the edge, enabling fully edge-native applications. Within 2 to 3 years, edge deployment will be the default for serverless functions. You won't opt into edge. You'll opt out if you need region-specific deployment. Platforms will automatically route requests to optimal locations based on user location, data location, current load, latency requirements, cost optimization. AI models running at edge locations for real-time recommendations, content moderation anomaly, detection, personalization. Current edge functions are mostly stateless. Coming, stateful edge applications with WebSocket connections, long-lived state coordination between edge locations. Every major database will have edge-native versions, global read replicas by default, write to nearest location, automatic conflict resolution consistency guarantees. The convergence of edge computing and serverless represents one of the most significant architectural shifts in cloud computing. We're moving from deploy to a region to deploy everywhere, automatically. For users, this means consistently fast experiences regardless of location. For developers, this means building global applications as easily as local ones. For businesses, this means competitive advantage through superior performance. The next is Section 4 AI and machine learning integration. Now let's dive into what might be the most transformative intersection in all of cloud computing: serverless and artificial intelligence. We're living through an AI revolution, and serverless is becoming the dominant deployment model for AI applications. This pairing makes so much sense that within 5 years, I predict 80% of AI inference workloads will run on serverless infrastructure. AI workloads have unique characteristics that align perfectly with serverless. 1. Highly variable demand. AI inference is bursty and unpredictable. Image recognition API might process 10 images per hour, then suddenly 10,000 chatbot has quiet nights and busy days. Document analysis spikes when reports are due. Traditional infrastructure, you provision for peak capacity and waste resources during slow periods. Serverless, you scale automatically from 0 to thousands of instances. Pay only for actual inference. 2. Expensive compute resources. AI models, especially large ones, require expensive GPU compute. GPU instances can cost $5 to $30 per hour. Traditional. Your $20 per hour GPU instance runs 24/7, costing $14,400 monthly, even if only used 20% of the time serverless. Your GPU is allocated only when inference is happening. Same 20% usage costs $2,880 monthly. 3. Model updates and A/B testing. AI models improve over time. You need to deploy new versions, test them, roll back if needed. Serverless makes this trivial. Deploy new model version, route 10% of traffic to new version. Compare performance metrics, roll out or roll back instantly. 4. Diverse model deployment. Modern AI applications use multiple models. GPT-4 for text generation, Whisper for speech recognition, DALL-E for image generation, custom models for specific tasks. Managing infrastructure for each model is complex. Serverless handles this elegantly. Each model is just another function with appropriate resources.